My name is Paxton Kianka, and I'm here at the scene of the crime. It's 10:57 a.m., and 1 hour ago, a citizen of this neighborhood was hit in a hit-and-run accident.
What is this? Why is it going so fast, yo? Dude, do you not see the van? Do you not see it? The bros of the road. Oh my god. Dude, man!
Hey,
Yo! What?
Come back! Wait, I'm calling the police! A tragic accident happened in this neighborhood. But was it an accident? We have here a witness to a crime.
Yeah, in the words of my dear chemist friend, they could not heal him, they could not cure him, so now they have to bury him. Thank you.
That's disrespectful. Sam, what do you have to say about hitting that citizen? Find out what the scientists have to say about it. I'm here with scientist Dr. Holden. Dr. Holden, would you care to tell us a little bit about atomic and ionic radii?
Yeah, of course. So atomic and ionic radii measure the amount of electrons that are contained in the atom. It leads to measuring the actual atomic radius and ionic radius of the element. This can be measured in picometers or nanometers.
Thanks, Dr. Holden.
The atomic radius measures half the distance between two identical atoms that are bonded. As you go down families, you add energy levels, which makes the atom bigger and therefore the atomic radius. As you go across periods, you add protons, which pulls in the outer electrons more. This causes the atomic radius to be smaller. An ion is an atom that has had electrons added or taken away. Now we measure the ionic radius. An anion gains electrons, making it negative. When electrons are added, either an energy level can be added to support it, or the similar charges of electrons can repel each other, making an anion bigger than a neutral atom. A cation loses electrons, making it positive. When electrons are lost, energy levels can be lost, and there is less electron repulsion, causing a cation's radius to be smaller than a neutral atom's radius.
This is a graph showing the atomic radius in picometers of each element on the periodic table by atomic number. The spikes in the graph represent the beginning of each new period, showing how, as you go from right to left along a period, the value of the atomic radius declines significantly. This second graph shows the atomic radius in picometers of each element by atomic number, but this time only group 1 and group 7. This shows how if you go from the top of the group to the bottom, the value of the atomic radius increases with each new energy level added. This is a 3D visual representation of the values of atomic radius for each element on the periodic table. As you can see, as you go from top to bottom in a group, the value increases as more energy levels are added, and as you go from right to left along a period, the value decreases as more protons are added, which attracts the electrons further into the nucleus. This is a 3D visual representation for ionic radius for each element on the periodic table. The blue are the negatively charged anions, and the pink are the positively charged cations. As you can see, the trends along the period and family are the same. The only difference here is for each element there are two values, and the anions are larger than the cation.
The atom with the largest atomic radius is cesium, and the one with the smallest is helium. There are two exceptions when it comes to atomic and ionic radius. One is with lanthanides and the other is with noble gases. For lanthanide, contractions have poor shielding of the 4f electrons, which lead to a decrease in radius rather than an increase. For noble gases are held by the van der Waals forces rather than covalent bonds, which allow them to have an increase in radius rather than a decrease.
Oh no, look. What? We accidentally put together the hit and run clip with the ionic and atomic radius clip. This doesn't make sense.
I have something very important to the development of the segment.
My God.
Received a clip anonymously sent in by a fan depicting Bruce's last words.
Circumnavigate ionic and atomic radius.
Dude, you good, bro? Dude, you good, bro?
My God.
Forever. Hey. Did you see the crime? Would you like to tell me?
I think there was a chemist there, and he said, we could not heal him, we could not cure him, so now they have to bury him. Did you get that?